Thank you for following and thank you for studying with Back Science Education Consultants. The real definition of continuity of quality education is us, the Back Science Education Consultants. Today, we are continuing with our lessons about electrolysis, and teacher Ambassador Osbert. In the last lesson, we talked about electrolysis of molten electrolytes, and we used kinetic theory of electrolysis to predict the product on each of the electrodes. I left a very simple activity, and from the responses from most of you show that I'm convinced that you understood. Today, we are going to talk about electrolytes also, but in this case, we are talking about aqueous electrolytes. So today, we are studying about electrolysis of aqueous electrolytes. Remember that an electrolyte contains ions. When these ions are put together and electricity passes through them, they get oriented, they get attracted to different electrodes, and when they reach those electrodes, they get discharged. In the last lesson, most of you presented good work. We had sodium chloride, which is molten, meaning it is a liquid, in our exercise, and most of you are having it here that this one contains only sodium ions and chloride ions. That when electrolysis of this is done, this one goes to the cathode and this one goes to the anode, and so respective discharge takes place. Thank you for responding, and I encourage the rest also to keep doing my exercises. Keep practicing so that we keep learning together. Now, we are talking about aqueous electrolyte. Do you know the meaning of the word aqueous? And B, aqueous solution is a solution with water as the solvent. When you have a solution made from water as the solvent and any other solute, then you call it an aqueous solution. Meaning that an aqueous electrolyte is this electrolyte that is containing water. Remember that water is also an electrolyte. If e.g., when you talk about copper 2 sulfate aqueous, you are talking about a solution which is made by dissolving copper 2 sulfate in water. How does electrolysis take place in such a scenario? It is what has brought us today. So, if you consider a solution of copper 2 sulfate, a solution of copper 2 sulfate. I want us to look at the ions that can be found in a solution of copper 2 sulfate. Being a solution, maybe to be specific, when it is aqueous, then it means that you have the contents of this solution as copper 2 sulfate and also water. In the solution of copper 2 sulfate, you have there copper 2 sulfate that is the solute, and then water as the solvent. And remember that whenever this one is dissolved in water, then it can easily break down to form ions. Which ions? Copper 2 ions and sulfate ions. And then water can form hydrogen ions and hydroxide ions. So, since we are talking about aqueous solution, then all of them will be aqueous, because this is a liquid. That means that when you have this as your electrolyte, you have copper 2 sulfate. Now, if you have copper 2 sulfate in this solution, this is the electrolyte, aqueous copper 2 sulfate, and then you create a circuit on this. This means, according to our battery, this is positive and this is negative. So this is the anode and this is the cathode. When you are having this electrolyte, it's the same way when you say that you are having copper ions, sulfate ions, hydrogen ions, and hydroxide ions inside this electrolyte. Therefore, it means that according to kinetic theory of electrolysis, if you have this as your electrolyte, it means that you will have in that solution copper 2 ions and hydrogen ions will be attracted to the cathode according to our theory. And then sulfate ions and hydroxide ions, both of them are attracted to the anode. Remember, anode is the positively charged, so it attracts the ones which are negative, and the cathode is negatively charged, so it attracts those which are positively charged. There is something which is very important and it needs to be noted. In the last type of electrolysis in our videos, it is very easy for you to know that this one goes here, the other one goes there, and so they get discharged and you form products. Because the electrolyte is very clear. It is containing only one substance. In this case, we have two ions in each type. We have in the positive ones, we have 2 of them, and also the negative ones are 2. Yet, only one ion is discharged at each electrode. This is very important. If only one ion is discharged on each of the electrodes, what will be discharged at the cathode? Surely, when we have copper and hydrogen, both of them have come here. Both of them copper and then hydrogen. Both of them are coming on this electrode. But we know of the two, we want only one. Which one are we going to choose? Of these two, sulfate and hydroxide, which one are we going to choose? There are three factors that affect our choice. There are three factors that affect our choice. And one of them factors that affect position of the ion in electrochemical series. You guys studied reactivity series, and you were having a song starting from potassium, then to sodium, to calcium, and the last one is gold, the one you like most. That is the reactivity series. There is also electrochemical series. They almost look the same. The difference is very small. Number 2 is the concentration of the electrolyte. So before you predict, you ask yourself, is this electrolyte concentrated or dilute? And then the last one is the type of the electrodes used. You will realize that in our previous experiments, we have always used graphite and we have not made a mistake to use iron, for example, because iron is a good electrolyte. To use copper, you cannot use copper in some cases unless you want specific products. So these are the three factors that such a scenario will based on to be solved. We shall use one by one. Each of those factors will be studied in details in our subsequent videos. Do not miss. We are around and we must continue learning. Meet us in our next video for more lessons. Stay safe and stay learning.